okay, we are on this is the fourth lesson, right? So we did like lambda calculus types, recursive types and functions. This was the previous lesson, right? The previous whatever you want to call it.
Yeah.
And okay, the plan for today is do type classes and records, probably in the other order. We'll probably start with records first and then do type classes. But
Okay.
before that, I guess we should look at like if you have any questions or if you just want to go over like the. I kind of hate calling it homework, but I don't have a better name for it. So
It's a homework. But I think the hardest part for me is I
okay.
feel like there are not enough tutorials on the internet.
Oh yeah,
Um,
that's
I feel like there's no documentation, for me to watch and actually help me understand. So the homeworks are very interesting in the way that I'm kind of in the darkness, I'm just
yeah, and that's why I keep telling you, and you haven't reached out yet. But I'll keep repeating. Like if you get stuck, just ask me, because I can
yeah.
definitely reply in between.
The the main reason why I didn't ask you so far is because I'd rather have like 15 minutes at the beginning of the stream where you just explain it to me,
Okay,
like,
sure.
because I don't want to bother you in your free time, so
I
doesn't.
mean, if I insist, that there's no bother, first of all. But then,
Okay, okay.
secondly, it's like if you get stuck and don't get anything done, like from
Okay.
this, then it's
Yes.
probably better to ask, right? Because then you kind of spend the whole week without doing any pure script, and I think it's better if you're able to do at least some. Um, yeah, but again, it's not a big deal anyway.
In my defense, though, I did
Okay,
download the Haskell tutorial. If
okay.
that's okay, maybe I can, do them at the same time. Maybe it helps because you said that the syntax is kind of similar.
It's almost
So,
identical. There's very, very little difference. There are a few gotchas that you need to be careful. And I think the
okay.
more we do more advanced stuff, then you will start to see the differences. But for everything I've taught you so far, I'm not sure if there is any noticeable difference. Other than, for
Okay.
example, main has a separate, like, kind of looks a bit different, and like the same program won't work exactly because you need to import other things, and you like, but like that's the only difference really until now.
Uh, okay. Well, I'll just start from tomorrow.
Okay, sure.
Um, okay. So we go for the homework now
Yep,
because I have some questions.
fire away.
Um, okay. So the the first exercise was to do the product of a tree.
Mm-hmm.
Uh, wait 1 second. Where do I paste it? At the bottom.
Sure. Well, actually, you know what you should do. So wait, do you see where my cursor is?
Yeah.
You should
Oh,
replace
okay. I
this
should
one because
just
otherwise,
replace.
otherwise you
Yeah.
get an error saying that it's redefined.
Yeah. And it does make more sense to do it like okay.
Okay, so let's see. So if you have an empty tree, the result is 1, and if you have a node with left, right, and x, you just do product tree left times x times product tree right. This looks good to me, so I think it's fine. Let's see if you get an error, you don't even get an error. So yeah, I think this is correct. Good job.
Okay. Now this is the count how many times we can find the n inside the t
Mm-hmm.
inside the tree. So I did this.
Okay, so let's see. So if we have an empty tree, then it's 0, and if we have if we're looking for x in a node, then if x equals y, then we add 1 to finding it left and right, and otherwise,
Here is where I have a question. Should I just put a plus here
yep,
like this?
definitely. I think
Yeah,
previously it didn't even compile when you had the or there, right? Because I don't think it would compile the way you wrote it initially.
it didn't give any errors, but
Oh, really?
uh,
Let's see.
oh, okay, okay, okay.
Right, so because the thing is, this is a number, right? This is a number,
Yeah.
and then this is a number, so you cannot or numbers because or only works on sort of
Booleans.
boolean kind of things,
Yeah.
right?
Okay.
Okay,
Yeah.
cool. Okay, so this is where it
Uh,
starts getting a bit trickier, right?
yes.
Okay, so let's see map 3.
don't be mad.
Why would I?
Okay, so this is what I wrote. Oh wait, I
I mean, it's
replaced.
fine. You can kill the comments as well. I don't care much about them. So let's see. If we have empty with whatever function, the result is empty. This is correct. So if we have a node.
Need help here because I don't know how to properly express it.
Okay, so explain to me what you're trying to write first. Like, what's the
Okay.
idea? Ignore what you wrote here, maybe, or if you want, you can try to explain what you wrote here. But just like, what's the idea? What do you think we need to do?
Okay, so if the tree is empty, then I get
That's correct.
the return is empty, so that makes sense. And then I wanna apply the function to the left and right, but this should be no, this is fine, right? Like this part.
Until the equal sign, it's good, right? Yeah.
Yeah. So this is where I don't know exactly how to express myself, where I wanna apply the function to the left
Okay.
and to the right, like to the two values that I select from here, from the node. And then I wanna do the recursive part of the function, like where I use map tree to left and the right part of the tree.
Okay, so let's do something else first. So let's look at this thing before
Yeah.
before we continue, right? So
Yeah.
let me just copy this, and then
Okay.
and let me put it here so we can see it while we also look at the function. Okay.
Okay.
So let me add a comment to it, and there we go, right? So let's
Yeah.
see, this is a tree we want to map over, right? So this is the tree.
Yeah.
So this is this argument, right? This, right?
Yeah.
What is f? Do you know, or do you want me to explain?
F is the function, the int to int.
So
It's
give me an
what,
example. Give me an example of a function from int to int. You can
like,
say it or type it, either way. It's up to you.
well, the one that we did was the one that pops to my head, like the +1.
Yep,
I add 1 to
sure.
all the elements of the tree.
Okay, cool. So the way we usually write this is this, right? We write it like this, like underscore +1. This is a function in Purescript, right? And the type of this is int goes to int.
Yeah.
Okay.
Yeah.
Okay, cool. So then, without thinking in Purescript, like, so just think about like, ignore the fact that we're using Purescript, right? And I think we need also like, or actually any programming language, right?
Yeah.
Just think about, okay, so if I give you this tree, right?
Yeah.
And I tell you to apply this function, how would you do it? Like manually, on paper, whatever.
I would replace 5 with 6, and then I would go to the left side and do. Actually, I wouldn't go to the left side. I would go here and be like 5, and then 11, and then 4.
Yeah. Okay.
4.
So the takeaway here is that we apply the function on the values of each node, right?
Yeah.
So we apply this thing. Okay. So let's maybe let's just move this away for a second now, right? So okay. So our function is f, right?
Yeah.
So what's our value in here? Where's our 5 in this? Like if we were looking at this node.
So it would be like f and x.
Yep. So that's how you get, like, if this was 4, that's how you get 5, right? So the result of this is 5.
Yeah, but
Correct?
I have to. Yeah, but I have to use node.
Yeah.
Right?
Exactly. Yeah.
Okay. So it's do I have to use a parenthesis here?
Only
No.
for fx.
Only for
Yep.
yeah.
Perfect.
Yeah.
Yep. That's good.
I was already going for it, and fx and then left like this.
So if we do this and then also write, for example, there,
Yeah.
then our function only changes the first node, not the rest of the nodes, right? So
yeah.
like if this is the input, then you'll get 6 here, and then everywhere else you'll get like the same thing as before, right?
Yeah. I wouldn't stop here, but I'm asking if this is like the correct notation so far.
Yeah. So now if you type right here and we save, then I think this should compile, or it doesn't compile?
Wait, it has an error on empty.
Oh, because it's not
List
called empty. It's empty3, not empty.
Yeah.
And then also on the right hand side, you also need to equals empty3.
Yeah.
There we go. And now let me do the save, and now it should compile. compile. Why does it?
The ints are not good enough.
Oh, okay. You know why it's wrong? Because we do left here, and then the middle is the x, right? So we have to keep the same shape as here, right?
Yeah,
So it's
okay.
left value and right, and then left value and right.
Mm-hmm.
Okay. So now it compiles, right? Everything's good. But
Yeah.
we're not changing left and right, correct?
Yeah.
So how do we do that?
I map tree the
Uh-huh.
left and right side of the like is this
Well,
okay?
not there. Okay,
No?
so
Okay.
instead of okay, let's think about this for a second, right? So right now, so note how many parameters that node takes. 3, right? Left,
Yeah.
fx, and right. So essentially, there is nothing we can write here in this space here that would work. We cannot
Yeah.
write here. So we have
Okay.
to replace left and right with something else, right?
Mhm.
Right. So maybe let's add parentheses around left, for example. Right.
Okay.
And then right's inside the parentheses. What would you put there?
Node of map tree left, right?
Okay, map 3. Yeah, that's good so far. And then there's something else you need to do there, because map 3 takes how many parameters does map 3 take?
F left.
Yep, there you go. That's right.
Yeah. And then I have to do the same to right as well.
Yep.
Okay. Well, in yeah, this. Okay. It only takes you like 10 seconds, but you help me understand way easier and faster. Okay, yeah, this makes a lot of sense now, because this is the first argument of the node.
Yeah,
So,
and like if you forget how the node looks like, you just look here, right? In the constructor. The constructor is the source of truth, right? This tells you how a node looks like, right? And like usually an easy way to write these functions, maybe I didn't even think about this so far, right? Like, or rather until now, right? But like an easy way to write this is, okay, so I'm starting from a node, right? And I also need to create a node. So maybe if you just type this first, right? Like we did earlier, this is a very good starting point, right? So, okay, if I do this, like your train of thought could be, okay, if I do this, then I don't change my node at all, right? I just return the same 3 as before.
Yeah.
Okay, so what does my function need to do? Well, it needs to call f over the x, right, over the value. And then what do I do with this? Well, usually you call your function recursively, almost always, right? Or you combine the recursive results somehow, right? So that's a good starting point. But again, this works when the result is also a 3, right? So when you're trying to keep the same structure, if you're going to a number like here or here, right, or to some value, then you don't have node on here, right? Because the result is an int, not a node. Right?
Yeah.
So it's a bit different. So when you do something like this, it's not really the same case. But if you do like things like map, for example, or you have to keep the same structure, then this like heuristic of like retyping this and then seeing what changes is probably pretty reasonable. Okay, so let's continue. Okay, this is the hard one, I think. The fold.
Wait, is it the fold next one?
I think that's the one after map, or at least that's what my notes say.
Yeah. This okay, this is what I wrote.
Okay, so let's see.
Okay, so I wrote kind of what I would like to do.
Okay, so let's see. First thing is, so you're missing, like you have the wrong syntax on this line, like on the line after fold 3, because you also need to write fold 3 of something. Like let me do, because like you need this here. Yeah. Okay. So let's see. fx empty. Okay, so I'm not sure what this is doing here. Probably something bad with the paste, right? But I think this is what you meant to type.
Yeah.
And I think this is right, except again, this needs to be empty 3, not empty, because empty is the empty for list. So this case is correct. Okay, so let me read this one. So okay, if we have a node, then what do you do? So we have a fold 3 fx. Okay, so this is sort of right. except that we can do this thing. So one thing that we're not doing anywhere, if you notice, is we're not using f anywhere, right? Because we're not using f here. Like we might as well do underscore here. And then here we're just passing it to the recursive function, but we're not actually using it.
Yeah.
And like this is not using it either. So this essentially means that we never use the f, right? So what's the idea with f? Can you guess what f does by looking at this?
After I think this is like an was it append, or like when you add the element to the bottom of the tree, right? Like you add it as the last element, because it doesn't do anything until it finds empty, and when the tree is empty, then X gets the.
Oh, I see. Yeah, you kind of could think about it like that, but wait, did I write this? Give me 1 second, because I think I either did it wrong or maybe you changed something. Let's see if it was me or you. Okay, you definitely changed the type for fold 3. If you see, like, I had it as int and somehow you changed it to 3int for some reason, which I'm not sure of.
I think I copy pasted before you fixed it.
That's possible. So let's do this, right? So the result needs to be int. And now this is correct, right? So what this does is basically what they say. Okay, so if you're trying to apply some complicated function, which we'll think about later, over an empty tree, I can't do anything, but I can return you the default int value that you're passing me. And we're just returning that, right?
Yeah.
Okay, so now if you give me this function thing, right?
Yeah.
And some x, I can do like, what's this? So what would this be like? Let's think for a second. So this has 3 parameters, like 3 inputs and 1 output, right? This function here. And our tree is kind of like, let me move the tree again. We'll keep moving this. Well, actually, I think this is the last function. Okay, so let's remove this. Right, so we have some function like this. Let's call it f, and then x, well, a, b, c, d equals to, let's say sum, right?
Okay.
Wait, that's wrong. It only has 3 parameters. Right, because like the 4th is a return value, right?
Yeah.
So our function f could be defined as this, right?
Mm-hmm.
So, okay, so let's see, and then, okay, don't forget that we're also getting some x, right?
Yeah.
Okay, so let's see, and krdvr, I think, has it right. So let's see. So we have this thing, right? We have like some, like we're in this case, right? Where we have this, and then we have this thing, right?
Yeah.
Correct?
Yeah.
Okay, so let's see. If we're in this case, we need to use a function f, right?
Yeah.
And then, but we only have one x, it's this, right? Or actually we have this y, right? So maybe we could type it here, right? So let's see. Let's comment this for a second, right? So we're here, right? So we could say fy, right?
Yeah.
And then, but then we need 2 more integers, right? Does that make sense so far?
Yeah.
And and what else are we not using from this?
Well, so we're not using the 3 integers in the int.
No. So I'm saying literally from this line, from the line 254, right? So we're using f, right?
Yeah. Yeah.
We're using
y. Using the y. We're not using the x.
Okay.
The left and the right.
Okay. Cool. So since there's 2 more, so okay. So and the point it would be like to kind of use all the values in the tree. That's probably the most important thing we need to do, because the x we're already using here, right? So it's not really that important to be using the x here, if that makes sense. Because what we're really trying to do, if this is our function, is to add everything in the tree, right? So like to do the sum tree that we have here. Where is it? Sum tree, right? So for example, we could be using sum tree, like we could implement sum tree using fold tree using this function, right?
Mm-hmm. Okay.
And I'll show you how in a second, right? But the idea is like, okay, so this means the current value, like y, right?
Yeah.
And this is the value for the lefts.
Integer, yeah.
And this is the value for the rights, kind of, right?
Yeah. Okay.
So, okay, how do we make it so that from left, oops, let's do this, right? So from left somehow, and then also from right. How do you like, what type is left here? Do you know?
Type as in
Like, for example, the type of this is this, right? Int to int to int to int to int.
okay.
The type of x is just int, right?
Yeah.
And the type of like this whole thing is 3int, right?
Yeah.
The type of y is just int,
Mm-hmm.
right? The thing in the middle. What type is left?
Left should still be a 3int.
Yep, exactly, right? Because there's two subtrees.
Yeah.
Perfect. Right. So okay, so we have a like a tree here, but we need it to be an int. So how do we go from tree to int?
From 3 to int. So I add up all the numbers from it, right?
I mean, it's not really add, right? Because what if, so what if we have a different example? What if I say that GABC is A times B times C, right? That could also be an example, right? Instead of F, we could use G here. So it's not really adding, but it's close.
By going over all of the values in the tree.
But how, maybe it's easier if you type, if you have an idea, or no. If you don't, I can't help you.
A type?
Like write it here, right, using your keyboard, typing.
Okay.
If you think you have an idea of what to write.
No, I actually have no idea because.
Okay, cool. Let me explain, because this is actually a bit complicated. So the way you can go from a tree to an int is using this function that we're defining. It's just a recursive call here, right? So you can do fold tree f x and then left. And then fold tree fx right. Does this sort of make sense?
Yeah, now it does.
Right, because like we're kind of like, okay, we have one int, but we need two more, and then we have a left and a right. How can we get from left to this? Well, we use the same thing, right? Or in other words, if we're here, how do we get, like, we can do f of 5 here, right? But then how do we get the two other ints? Well, we call the same function here, and then when we're here, how do we get the rest? Well, we go further, right? And we do this and this. And then when we reach this, we get back the x, right? So like for addition, x will be 0, right? So it will basically put 0 in all of these places, right?
Yeah.
And then it will just add everything up, right? Because that's what we're doing. Right? And if x is 1 and f is like this 3 thing multiplication, then all of this become 1, right? And then you just multiply everything, right? So for example, using this function, which I think should compile now, we can define like sum 3 prime, which equals to fold 3 of some function. Let's just say go here, and we'll define it later with the 0, 3, and then okay. So let's sum 3 goes from 3 int to int, right? That's the way this works. Go 0 and then t, right, for whatever tree here, right? We don't even need to pattern match. You can say here where go a b c equals to a plus b plus c, right? And this sum 3 works exactly like the one that we defined manually above, right? Where is it?
I think you passed.
Oh, sorry, that was the int. Yeah, this one, right? Right, but instead of pattern matching here, we kind of use fold for that.
Yeah.
Right, and we can define product, and we can define a lot of cool operations using fold tree. That's why folding is a important operation. Okay, but again, so don't worry too much if this is complicated, because we'll have a whole chapter on foldable probably later. Which is like a whole different thing. So this was probably a bit too hard for me. Okay, so let's see. So the list string.
This is where you checkmated me.
Okay. So I think toString is the first thing that you need to replace. It's down here.
Yeah, my bad. I actually copied
no problem.
it as well. Okay, so I have no idea what to do here because, well, first thought was to just show int, but it doesn't work to do it like that. And then,
Okay, so let's start over. So let's see. So we have a list of okay. So we have a list of integers on the left hand side, right? And we need to get a list of strings. So this is okay. So let's see. First thing is, so this list here. What should we do with it? Like, what's the only thing that we can do with a list int, like, or the usual thing that we do?
I can
Like, let's look at all the functions here that we did over list, right?
yeah.
Like, well, other than this one where we just make values, right?
Yeah.
So look here, it's count and then sum and then product and then find and then like everything else. The common pattern is that we always like pattern match on the list, right?
Yeah. Yeah.
Okay, so let's try doing that here as well, right? So instead of L, just pattern match on the int list.
So
what are the cases for a list int?
well, it has empty ls.
No, wait. No, that's the string list, right? So let me copy this over.
Oh, okay.
Right, so we're going from list int to list string, right? So on the L is a list int, right? So here we need to pattern match on list ints constructors, right?
So it's empty.
But it's here, not on the right. So on the left hand side is a list int, right, which is empty. So if we have a empty list of integers, what kind of list of strings can we create?
So if the list is empty, then I get it's either 0, right?
Well, no. So what's list string? It's this, right?
Yeah.
So list string can only be empty ls or make string list, or list string rather.
Empty ls.
Yep, exactly.
Ah, okay.
Right, so you're kind of saying, okay, for this constructor in list of integers, the quote unquote equivalent of it is this kind of. That's what we kind of need to do.
Okay.
Does that make sense?
Yeah, no, it does. I didn't really understand what.
Right, because we're going from a list of ints to a list of strings, right? That's the idea. Okay, cool. So now, okay, let's rewrite this, right? So how do we pattern match on the left hand side on the what's left for list int?
For list int, we have wait, where is it? It's make list. List int.
Okay, so replace L
make
with
list. No.
Or you can just delete as much as you want.
Okay.
But then this L doesn't make sense here, right?
I was
anymore. Okay, cool. So it's make list int, and what do we have here? Like, what's the arguments? Let's just type them instead of an underscore. Like, it's some.
So we have the empty.
Why is it empty? Like make list int. Actually, it's just make list. It's not int. It's just make list, right? And then the first thing is an int and then a list int, right? These are two different arguments here.
Yeah. Okay. So int.
Sure, you could just write x if you want, or int is just.
Yeah, I wanted to make it.
Okay, sure. To make it easy.
I think it would be a bit easier. Yeah.
Okay,
and
sure.
List int. Okay.
That's fine.
So.
Okay, so what was the result, right? So let's look here at this example, right? So for example, you have a list with 1 and 2 and then empty, right?
Yeah, and it returns 2 strings, 1 and 2.
No, it returns a list of strings with 1 and then string 2 and then empty, right?
Yeah.
Okay, so what's the first thing we need to write here?
Here is where I have to create the list of strings.
Yeah.
So
good.
I have to go through the constructor of.
Yep, that's perfect so far. And now, so what's the first thing that we need to pass to it?
So the string that I have. So it's string like this, or.
Well, you don't have a string, right? You have an int, so you need to convert this int to a string, no?
Yeah, but like, I don't know how to. Is this where I use the show function? Like,
exactly.
Okay, because in my defense, we never did this. So I felt like it would be very awkward to just like, is this what I'm supposed to do?
Nope, you just write show space int.
Ah,
Because show is just a function and int is its argument, right?
mhm. Okay. Show in, and I still need the list, right? For
Mm-hmm. But what kind of list do you need on the right hand side?
the string list.
Mm-hmm. So, and what argument are we not using from this
List
line?
int.
Okay, so we have a list int and we need a list string. What function do we know that goes from list int to list string?
The concatenate one, right?
Well, no, concatenate goes
No,
from
no,
list
no,
int
no,
to
no, no.
list int to list int, right?
Yeah,
It's we literally have one list of ints, right?
yeah,
And we need to make a list of string.
yeah. To string.
Yep, exactly.
Yeah.
Well, you got a syntax slightly wrong because like this, you need to close this parenthesis here, right?
Yeah,
And
yeah,
open a new one here, and then toString takes a parameter, right?
yeah. To string of list int.
Yep, I think that's correct.
Mm.
Yep, that's good.
Okay. Uh,
Again, this is something that's a bit tricky. So this, in general, it's called a well, it has a very tricky name. It's called a natural transform. And the idea here is that you convert, or maybe it really depends. You could see it as natural transforms. This is different types or a map, general map. But the idea is like you kind of like if you have two different types, like on the left and right, usually go for something like this, right? Okay, what kind of things can left thing be, and then map it on the right? So it's like empty goes to empty, and then list goes to like list or something like that. But then you also have to like apply some function to each part, right?
Mm-hmm.
Okay.
Okay. I actually understood this one, but I don't think we've done this together, so it
No,
kind
I
of
don't think we've done something like this
yeah,
before.
it blew my mind when I saw it. Just
Okay.
Okay, and then the concatenate one, which okay, oh wait, am I? Oh, okay, okay, because I
Okay, so on the right hand side here, on the first line, so the result needs to be a string, not like empty is a list, so this will not work. Empty is list of ints.
yeah.
But we need to do like just a simple string.
Uh,
Not even that, because ls is a list string, right? But we just want a actual string.
yeah. So can I do something like
Yep,
this?
exactly.
Uh,
I mean, you could even just do an empty string like this, right? And that's also fine.
yeah. Okay.
Right?
Mm-hmm.
Okay. And then I guess you're stuck here,
Uh,
or
okay. Well, now let's see what I learned so far, because I go from list string to string. I have mkey list, so I use the constructor to
wait, what are you doing? Because it was right. It was more right before.
okay. I was just wanting to I wanted to go from the start. I don't know. So I have the string and the list string.
Yeah. So x is a string, right?
Yeah.
And rest is.
That's what I
Oh, you're
wanted to
going to
replace
type.
it
Oh,
with
okay,
the
sure. Sorry.
names.
Sorry,
Yeah,
do
yeah,
that.
yeah.
Sorry.
So it's easier when I see it again.
Sure.
Okay.
That's fine.
Okay. And now I have to make the list again. No,
No,
I don't have to because
you
it
just.
returns the string. Yeah, got it. So this time I have to apply the function that you showed me. The so do I go like
Yep, that's good so far. But
and
then, so
I think
this
here
thing. Okay, go ahead. Go ahead, I'll let you try. Yep, exactly. That's it.
Okay, like I swear to God, it makes no sense in my head, but as soon as you explain it once to me, it just
So
goes. Okay,
I hope you meant it didn't make any sense, right? Because now I hope hopefully it does make some sense.
yeah.
Okay, cool.
Okay,
And you
now
don't need
it makes a lot
parentheses.
of sense.
When you have an operator, you don't need parentheses. But it's not an
Okay,
error to add them. But
okay.
it's fine. Okay, so were you able to figure out how to write these two functions?
Hmm. So see the last line of the homework, but
Sorry, did you see? Because I think it got cut off. You said you didn't see it.
yeah, I'm sorry, but I
No
didn't
problem.
see the last line of the
Okay,
homework.
cool.
Yeah, okay.
Do you want to try to do it now, or do you want to try to do it for next time?
Mm, mm,
Up to you.
let's try to do it now.
Okay.
Okay, so map list string.
So how would you start doing this?
Okay, so I know that it's a function.
Mm-hmm.
Can I just get the map tree and look at it? So,
Do you think map3 is the closest thing, or maybe some other
no,
function
I
is
have a
closer?
map function. Wait, I'm gonna. Okay, found it.
You can literally just copy and paste it here. I
Yeah.
don't
That's
consider
what I
that
wanted
cheating.
to do.
So which
No.
one did you get? Okay, the listing, exactly. That's the one that's that we need, right?
Yeah, I actually looked. I looked at it before we started
Okay,
the
so
stream.
let's
Okay.
see. First thing is let's rename it, right? Because it's already defined, so we'll get an error if we don't rename map
Yeah.
everywhere
So
here.
it's map list string.
Mm-hmm.
Let's just.
You can just
Rename
type ls if you don't want to type everything, or Jack up to you. You can just type everything as well.
I just buy more time to think.
Sure.
Okay.
Okay. So did you replace it every, or are we forgetting something?
No, because I need. So first of all, I get the function, right? So
No?
this is f.
Oh yeah. You're right. Yeah. Okay. Sorry. Go
F.
ahead. I don't want to.
Okay. And then I know that I need. So I get a list int and it returns the list int.
Well, this needs to work on list string, not list int, right? So we need to change that, right?
Yeah. Lost myself in the.
Okay. And then can you see any other thing that we might need to change here?
Yes, the
okay.
two ints.
Yeah, and what should be there?
It should be string.
Yeah.
String to string.
Yep. Perfect.
Right.
So the first line is correct now.
Okay.
Second
Okay.
line.
So now I get this where the f is the function, right? And instead of empty, should it be empty ls?
Yep. Exactly.
And it equals empty ls.
Yep. Perfect. Second line is now correct.
Okay. And now map list string f, so the function, and then I make the list string.
Yep. That left part is correct now.
Okay, so again I go for
Sure.
int and list int, just
Are
so
you
it
sure
makes
it's
more
int
sense.
and list int?
No, because that would be stupid. It would be string and list string.
Okay.
Okay. And now I have to create the two pattern match for
No,
not
so
the
pattern match is
this
on the left hand side of equals.
yeah.
Construct
I
is on the
corrected
right
this.
hand side. Okay.
Yeah. Okay, so make list string of f string.
Yeah.
And then I map list string the f and list string.
Yep, I think that's correct.
Okay.
Let's save it, and yep, it compiles, and I'm fairly certain it does the right thing. So good job.
Okay. Well, thank you for having patience with this because
absolutely no problem. That's what we're here for. Okay, so do you want to try also to do full list string? Like you can do it the same.
Yeah.
You can look for like the closest fold that you think you'll find, and just replace things from int. You don't need to try to do it from memory or something.
My question would be, Can I use the mapping as a I mean, the closest that I get. Wait, I think
I
the
think we
order
literally
is the
have a
same.
folds list somewhere.
I found it. I found it.
Okay.
I can paste it. Paste it now. Wait,
Okay.
this is the one, right?
Sure.
Yeah.
We can do it like this. So how do you think it will look like?
So first of all, we get the string to string to string,
Mm-hmm.
and of course, little s,
Mm-hmm.
and of course, every int gets replaced with
Mm-hmm.
a string. So this one is the easiest one.
Yep. That's correct.
Okay. So for the string, let's go. So I get the function,
Yep.
and then I get the next string,
Mm-hmm.
and then the empty list, which would be
Mm-hmm.
the list string, and it returns the element, so it's the x,
Yep. That's correct
right?
as well.
So now I get fold list string of fx, and now we go for the pattern matching.
Yep.
Uh,
Mm-hmm.
uh, y and the rest. Actually, let's go for the
Yep. That's correct.
okay, and it equals to fy.
Well, do we have a y here?
What?
You don't have any y's here, right? You
Yeah,
renamed
yeah,
it,
yeah.
so
F string.
yep,
Yeah, that's what.
correct.
Yeah.
That's
Okay.
good.
And then we the fold this string of
Yep.
f and x and the list of string.
Yep, that's correct. You just need to you typed it
I
wrong.
need to type it in the
Yeah.
right list. Ah, okay.
I think it's correct now. Yep, there we go. Good job.
Yeah. Okay.
Yep, it's correct now.